Lesson 3.1 is properties of parallel lines, and our objectives are to identify angles formed by two lines in a transversal and prove and use properties of parallel lines. So we've got a few key concepts and a lot of vocabulary today. The first one is postulate 3.1, which is the corresponding angles postulate. This says if a transversal intersects two parallel lines, so over here on the right we've got these two parallel lines, and this is our transversal that intersects them, okay? If a transversal intersects two parallel lines, then corresponding angles are congruent. Now, I think of corresponding angles as being in the same location. So like angle 1 is in the top right corner of the first intersection. Angle 2 is in the top right corner of the second intersection. So those two are corresponding angles and they are congruent. All right, theorem 3.1 is alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So this one is exactly what the words mean. So alternate meaning opposite sides, interior meaning inside. So alternate means they have to be on opposite sides of the transversal and inside of these two parallel lines. So angle 1 here, and angle 3 are on opposite sides of this center line and inside the two parallel lines. So angle 1 and 3 would be alternate interior, and they would also be congruent. Okay, so then if we're looking at theorem 3.2, same side interior angles theorem, if a transversal intersects two parallel lines, then the same side interior angles are supplementary. Remember, supplementary means they make a straight line, so they add up to 180. So here, these two are inside the parallel lines and on the same side, so angle 1 and angle 2, if you add them up, would have to add up to 180 degrees. All right, let's check out some of our vocabulary. A transversal is a line that intersects two coplanar lines at two distinct points. Okay, so it doesn't always have to be two parallel lines. A transversal just intersects two lines. So like here, L and M are not parallel, but T is still a transversal. Okay. Alternate interior angles are inside the two parallel lines, or two coplanar lines if they're not parallel. And on opposite sides of the transversal. So, angles 1 and 2 are alternate interior angles. Same side interior are inside the two lines, or two parallel lines depending on the situation. Inside two coplanar lines. And they're on the same side of the transversal. So, if we stick with angle 1, angle 4 is also inside the parallel lines, or the coplanar lines, and on the same side as angle 1. So that would be the same side interior angles. And corresponding angles are angles in the same location. All that means is if we picked up one intersection and laid it on top of the other, they'd be in the same spot. So, like here, angle 3 is in the bottom right corner of this top intersection. Angle 8 is in the bottom right corner of the second intersection. So angle 3 and angle 8 would be corresponding angles. Okay, a 2-column proof is reasoning. Just like any proof, it uses reasoning where one column shows what we know. So we're going to say shows statements about what you know. And the other column explains why. Tells us why you know those things. So that would be like backing yourself up with theorems and postulates and things like that. Okay. So then in the picture, it kind of gives you a description. They say, hey, line A is parallel to B. We want to prove that 1 and 3 are congruent. So we're going to say, okay, I know this because this theorem, I know this because this theorem, and so on until you've proven that for sure you know that's true. All right, so jumping into the examples. Applying properties of parallel lines. It says in the diagram, Lafayette Regional Airport, the black segments are the runways and the gray segments are taxiways and terminal buildings. Compare angle 1 and compare angle 2 and the angle vertical to angle 1. So we've got this angle and the angle vertical to angle 1. Classify the angles as alternate interior, same side interior, or corresponding angles. The angle vertical to angle 1 is between runway segments. Angle 2 is between runway segments on the opposite side of the transversal, or the runways. So angle 2 is right here. So they're both inside these two lines, but they're on opposite sides of this center line. So, because angle 2 and the vertical to angle 1 are not adjacent, so they don't share a side, and they lie between the lines on opposite sides of the transversal, angle 2 and the vertical to angle 1 are alternate interior angles. Interior. Okay. Let's take a look at number 2. Finding the measure of angles. In the diagram at the right, line L is parallel to line M, and line P is parallel to line Q. We want to find the measure of angles 1 and 2. So we know angle 1 and the 42-degree angle. So angle 1 and this angle, well, they're both in the top right corner of their intersection, so we know those are corresponding angles. Because they're in the same position. We also know that corresponding angles are congruent. So since these are parallel lines, we know the measure of angle 1 equals 42 degrees because the corresponding angle is 42 degrees. And this is because of the corresponding angles postulate. So in geometry, you always have to have a postulate or a theorem or something to back you up, not just, so we know it's not just you saying, hey, I think this is true. It's like, for sure, I know this is true because I have this piece of math that proves it. Okay, because angles 1 and 2 are adjacent angles that form a straight line. Straight line means supplementary, so we know that angles 1 and 2 add up to 180 degrees by the angle addition postulate. If you substitute 42 degrees for the measure of angle 1, you know 42 plus angle 2 equals 180. If we subtract 42 from both sides, we find that the measure of angle 2 is 138 degrees. Awesome. All right, let's look at number 3. Number 3 says use algebra to find angle measures. Okay, in the diagram, L is parallel to M. Find the values of A, B, and C. So, if we look at this, let's focus just on the parallel lines. And then this one line, I'm going to extend it. So now I have a transversal, which we had before, it just didn't look the same as what we've been talking about. Okay, so angle A, well, if I look over here, I know that this angle is 65. They're both inside the parallel lines on opposite sides of the transversal. So I know that those are alternate interior angles. And the alternate interior angles theorem says that those two angles are congruent, so I know angle A is 65 degrees. Then I want to find angle C. So if I look at just this line in the parallel lines, I've got a new transversal. Angle C and angle 40 are also alternate interior. Okay, and again, this theorem tells us that these are congruent, so C has to be 40 degrees as well. Well then, we still need to know what angle B is. A, B, and C all add up to make this straight line. So if I know A and C, A plus B plus C should add up to 180. So A plus B plus C equals 180 degrees. By the angle addition postulate, we know they make a straight line, so it has to be 180 degrees. We know A is 65. We don't know B, but we know C is 40. And it still adds up to 180. If we subtract those over to the other side, we will find that B is 75 degrees. Okay, you've just got a couple examples to do today. Number 2 has a few parts, but I think we can handle it. Okay, this one says use the diagram in example 1 to classify angle 2 and angle 3 as alternate interior, same side interior, or corresponding angles. So those are your only 3 choices. Okay, look at that diagram. Then number 2, use the diagram in example 2 to find the measure of each angle. So we look up in example 2. We're going to use this picture right here to find the measure of each angle, and then please do not forget to justify each answer. So you need to have a theorem or a postulate that tells us why you know this. And then 3 says find the values of x and y, then find the measures of the 4 angles in the trapezoid. Remember, it shows you that these 2 lines are parallel, right? We can extend those out, and then these 2 lines are just different transversals. So first focus on one side and then the other side. Okay, so that should help you to find x and y. You can use your different types of angles to solve for those. So look at them as transversals, not as just one shape, and that should help a lot. Okay, go ahead and get started. Make sure you're checking your answers with me. If you need anything, let me know. Good luck.